Assalamu alaikum everyone and welcome to Mathematics with Shahab Yaqub. So remember we were on algebra and we completed 21 lectures of algebra, but there is much more to algebra. So now we are on inequalities and this is part 2. So let me first recap what have we done exactly in inequalities. So let me roll up. And we got started with inequalities. This is greater, lesser, greater than or equal, lesser than or equal. We have shown inequality on the number line. We solved simple problems related with inequalities. One of the thing was if the coefficient of x is negative, what do? We divide both sides by -2 in order to make x the subject and the inequality flips. If the coefficient of the variable is negative and when we remove the negative sign either by multiplication or by division, inequality flips. So let me highlight this thing. And another method was that we changed the side. We brought this thing over here, we brought this thing over here. 2x is greater than or equal to 6, therefore x is greater than or equal to 3. The inequality is read from the perspective of variable. Then we solved simple questions like these. Set notation, not part of the syllabus for inequalities. We solved some inequalities in which compound inequalities. That means there were two inequalities. X is greater than 3, lesser than or equal to 9. When we solve this, 2x plus 2 is greater than -4, lesser than 6. So we solved it separately and we plotted the result on the number line. If they are traveling in opposite direction, the overlapping region, the common region is the answer. And then we had to involve the knowledge of coordinate geometry. So we went to coordinate geometry. And that was lecture number 1. So now we are starting with lecture number 2. Let me highlight what exactly have we done. So first of all, green is what we have already completed. And this particular red one, not this one, this reddish over here, that is the one that needs to be done. So now over here, let me focus on this thing. Represent and interpret inequalities including on a number line. So when representing and interpreting inequalities on the number line, open circles should be used to represent strict inequality, only lesser, only greater. That is what they mean by strict inequality. And then closed circles, that means solid circle, should be used to represent inclusive inequalities. So instead of open, let me write empty circle. And instead of close, let me write solid circle. And we already have gone over it. So question number 1, concept number 1 is done. Construct, solve and interpret linear inequalities. So this is construct, this is solve, this is interpret linear inequalities. As far as interpretation is concerned, that we will do a little bit when we will be using the past paper questions. So over here, past paper questions, we will be interpreting it. Something like multiple or some other words. What are the different multiples? What are the different possible integer values? So the interpretation will be coming on later. So these are past paper questions. So let me just highlight this, something like this, that will be coming later on. Now the third thing is represent and interpret linear inequalities in two variables. This is for today. So this is what we are going to get started today. linear inequalities in two variables graphically. So now we will be drawing it on the graph. The following conventions should be used. Broken lines should be used to represent strict inequality. Solid lines should be used to represent inclusive inequalities. Shading should be used to represent unwanted region unless otherwise stated in a particular question. So if we shade a region, that means that is not the region that we require. Shade is unwanted. So shading is unwanted. Keep that in mind. Example, if x is lesser than 1. So that means this is lesser, therefore it's a broken line and we are going to the left of this particular line because all these values are lesser than 1. So this is unwanted region, this is the required region. So let me also write this thing, that the required region is the unshaded region. So required is unshaded and unwanted is shaded. Y is greater than or equal to 1. So all the values of y above this line will be greater than or equal to 1. Since this is an inclusive inequality, it's a solid line. And then less inequalities that define a region that is naturally connected with this one. It's not something separate. So these two are exactly the same. So let me just draw a line like this from here to here. It is exactly the same, and I'll just pause for the azan. So now let's get started. And one other thing that I want to emphasize on, that is this concept of linear programming. It's a very different topic related to word problems and inequalities. That is no more part of the syllabus. So they have just specifically mentioned linear programming problems are not included. Now let me get started with this idea that let me draw a line. Let's say, let me draw a line y is equals to 1. So over here, this is y-axis, this is x-axis, this is y is equals to 1. If I shade this region, that means this is the wanted region. This is required region because all along this region, all the points in this region are such that the y coordinate is greater than or equal to 1. So let me write this inequality is y is greater than or equal to 1. That means if I want to shade a region, I should first draw the equation and then I should shade unwanted region. So shading question, shading problems, they are like this. First draw the equation, shade the unwanted region, and then you have solved the inequality graphically. So shading problems, graphical shading problems that are like this. Okay, now let me just have a look if there is any issue. Now the next one. This time, again, I'm labeling the y-axis, the x-axis. Let me draw this as in red color. Let me draw it in blue color. A line like this. This is the line. It's passing through 2. It's a line parallel to y-axis. This is the line x is equals to 2. Now the question would be shade the region. Actually, we are interested in the region x is greater than or equal to 2. So let me shade unwanted region. So now all along this line x is equals to 2. On the right, it's greater. On the left, it's lesser. So therefore, I am interested in shading the unwanted region. So therefore, this one is the required region. Similarly, over here, this one is the required region. So now we can generalize. How can we generalize? We can say that the greater is to the right, lesser is to the left, greater is above, lesser is below. So let me just generalize. Let me draw this box. Let me draw another box. That is solid is greater than or equal, lesser than or equal, inclusive inequalities, and dotted is simply greater, simply lesser. Right of a line could be greater than or equal. Left of a line could be lesser than or equal to. And above a line could be greater than or equal to. Below a line, this is lesser than or equal to. So this is the unshaded region. So let me just focus on this. Something like this. We are talking about unshaded region. And this thing is there, solid, dotted. All good? Now, when we talk about right of a line, we are talking about the equation of the form x is equals to a line parallel to y-axis. And when we talk about above and below, we are talking about a line y is equals to a constant line parallel to x-axis, or line of the form y is equals to mx plus c, that will also fall into this category. So let me draw some examples related to that. Let's say this is y, this is x, and let me draw a line y equals to x. Now this point is 0, 0. Let's say this point is 1. This is 1. Let me draw it properly. Or let me just mark this. Let's say this is 4 and this is 4. Now, if I am interested in this one, this is a point A. This is 4, 8. So A is 4, 8. Now, this shows that y is greater than or equal to x. So this point A is above the line. A is above the line such that the y coordinate is greater than or equal to x. This point B, B 4, 4. This is y is equals to x. This one is y is greater than x. That means I can write that all points above the line are such that y is greater than x. And if this line is a solid line, so let me choose a precision eraser, that is, I'm just making it dotted like this. So now it's a strict inequality. So therefore, I should shade this region. This is the unwanted region. The proper region is above the line. Is this all good, all clear? So now I won't go much deeper into this because this is just a basic kind of question. Just remember the standard. We will just follow this. Something like, let's put in two inequalities. I have y is greater than or equal to 0, x is greater than or equal to 0, y is lesser than or equal to 2. And I think, let me also write four inequalities. X is lesser than or equal to 5. There are four inequalities. This is y-axis. Y-axis is x is equals to 0. This is x-axis. X-axis is y is equals to 0. That means y is greater than or equal to 0. It should be above the line, the wanted region. The wanted is above the line. X is greater than or equal to 0 to the right of the line. That is what we are requiring. So we are basically in this first quadrant, but it's an open quadrant. We are limiting it. Y is less than or equal to 2. So let me draw the line. Y is equals to 2. It is lesser than or equal to this. And x is lesser than or equal to 5. Let me make it smaller. X is lesser than or equal to 4. So let me draw a green line like this. So now this is x is equals to 4. This is y is equals to 2. Y-axis x is equals to 0. X-axis y is equals to 0. Now, which is the required region? Think about it. It's to the above this line. It's below this line. So it's stuck between these two lines. It's to the right of the y-axis. It's to the left of the y-axis. Less is left. That means the required region is this region R, and the unwanted regions are this thing. This shading is there, this shading is there, then this shading is there, then this shading is there. So the number of inequalities are the number of sides. Remember this. Number of inequalities is the number of sides of unshaded. That is the required region. Is this all good, all clear? So now let's move on and let's focus on some questions. The concept is as simple as this. Of course, there will be some past paper questions with something more trickier, something out of the box, something like that. Now, graphing inequalities, an inequality can be represented on a graph. To do this, turn the inequality into an equation. So this is the step that we are talking about. Turn the inequality into an equation, draw its graph, and then shade the required region. Over here, the required region is shaded unless proven otherwise. For our syllabus, shade the unwanted region. It will specifically based upon the question. So it says on a graph, shade the region that satisfies the inequality. Now, since it says shade the region, we have to shade the region. So this is y is less than or equal to x plus 2. So which line should we draw? We should draw the line y is equals to x plus 2. Just take a point when x is 0, y is 2, when x is 1, y is 3, and so on. And very simple, that is less than or equal to, y is less than or equal to x plus 2. Yes, this is one thing that's very necessary, that the inequality will be read from perspective of y. if there is a y in that equation. If there is no y, naturally it will be read in terms of x. So y is less than or equal to x plus 2. This is a solid line, and this is the required region because it's below the line. So this is below the line. So it fulfills exactly the criteria that I have taught you over here. That's exactly over here. Let's move on. Now in exercise 1, it says draw a graph and shade the region that satisfies the inequality. Now, for example, x is less than or equal to 2. So draw the line x is equals to 2, draw a solid line, and this required region is shaded. Y is less than x plus 1. Okay, let me just focus on this. Question number 2, part A, and question number 2, part D. So let me grab a grid. Let me grab the same grid, and this is y is less than x plus 1, part A, 2, part A, y is less than x plus 1, and this is part D, y is less than or equal to 5 minus x. Now y is less than x plus 1, draw the line, y is equals to x plus 1. So the line goes like this. This is y is equals to x plus 1. We are shading the region, required region, less. So therefore, this is the required region. So this is required region. And over here, y is less than 5 minus x. So draw the line like this. It has a negative gradient and a positive y-intercept. So this is 5. This is 1. Negative thing. And again, we are shading the required region. So over here, this is also less. This is a solid line. And this line has to be dotted. So this black one is the dotted line. Since this is not inclusive, therefore it's a dotted line. And the general idea is that the questions that come, that is related to what you call something like the diagram is already drawn, and then you have to define the region. Now it says on a graph, shade the region that satisfies the inequality. How many inequalities are there? 3. So now y is less than x. Therefore, draw the line y is equals to x. And it's less. So this is below the line. So let me write over here. This is dotted. And below, since we are shading it, below needs to be shaded. X is less than 3. This is also dotted. And this is left needs to be shaded. Y is greater than or equal to 4 minus x. This is a solid line, and above needs to be shaded. Above region needs to be shaded. So that is what your thinking process is. So now let's focus on this. So we have y is equals to x, that is dotted. It's below this line. So below could be anything like this. And x is less than 3. This is x is less than 3. It's left of this line. So below this dotted line, left of this line, above this line. So therefore, this is the required region. Maybe if this was an exam question, then this is the unshaded region like this. And this is the unshaded, this is the shaded region like this, and the unshaded is the one that I'm interested in. This is the thing. So therefore, this is what is required over here. I hope you got the idea loud and clear. So more questions like this, but instead of these questions, I'm more interested in this thing because that is more exam type question. So this is ETQ, exam type questions. Now let's see what does it say. It says to find inequalities represented on the graph, find the equations of the boundary line. That needs to be highlighted. Find the equations of the boundary lines and then decide which inequality sign to use. We know that above, below, right, left, that's standard, we already know. Now over here, let me focus on this. Let me draw the first line in green color. That sounds very thick. Okay, maybe it's that because I have highlighted it. So now this green line, this is y is equals to x. Then let me choose another line, the blue line, that is y is equals to 1. So blue line, that is y is equals to 1. And then let me choose the red line. Over here, the red one. That is the line, which one? So the red one is what? That is x is equals to 4. Now it's a triangle. There are three regions, there are three boundary lines. Now it's below this, below the green line, yes. Above the blue line, yes. Left of this line. All these lines are dotted. That means they are strict inequality, only lesser or only greater. Now let me write it down. For the green one, I'll write below y is less than x. Why? Because it's below the line. So this region is below the line. The wanted region, the shaded region is below the line. And for the blue, what is happening? It's above. So y is greater than 1. For the red line, it's to the left. X is lesser than 4. So now the three inequalities, y is less than x, less than or equal to, it's solid. So this one is solid. That's my mistake. Let me write it. So solid is inclusive inequality. So this green one is solid. So let me just make it solid like this. Y is less than or equal to x. The thing is done. Y is greater than 1. That is the blue one. X is lesser than 4, that is the red one. That is how we do this particular question. So let me pause the recording over here and let me give you some more questions to try out like this. And I would like you people to try out this particular question that you see on the screen. So now let's look at this exercise 3 questions. It says write down the inequality represented by the shaded region. So the shaded region is the wanted region. We have a solid line that's right over here. This line is a vertical line. It's of the format x is equals to 3. The wanted region is to the right. The answer is x is greater than 3. Over here, we have a solid line. This is the line y is equals to 4, a line parallel to x-axis. The required region, the wanted region, the shaded region is below this line. So y is less than or equal to 4. Over here, this is the line y is equals to x. It's a dotted line. This is below. So therefore, this is y is less than x. This is solid. This is dotted. This is right. This is below. This is also below. These are the few pointers that you need to look for. And then this equation, question number 2, 2a, the equation is x plus y is equals to 4. You can double check. And it is a solid line. And the required region is below. So therefore, make y the subject, or it can be written as it is also, but x cannot be made the subject. So y is equals to 4 minus x, that's the equation, and y is less than or equal to 4 minus x. Why? Because it is below. And same goes for part B. I think this equation is y is equals to x plus 1. The gradient is 1, change in y is 1 unit, change in x is 1 unit, therefore the gradient is 1, the y-intercept is 1, and now it is above. So it's a solid line, it is above, y is already the subject, so y is greater than or equal to x plus 1. This one over here, let me calculate the gradient, that is 4 over 2 with a negative sign, that is negative 2. Y-intercept is 4, equation is y is equals to minus 2x plus 4. And now this is a dotted line and we are looking for below, so therefore y is less than negative 2x plus 4. If you want to write this negative 2x on the other side, that is perfectly fine. Y plus 2x is less than 4, this is also fine. But when we have x and y, it's necessary that y should be the subject, or both y and x could be the subject. Only x cannot be the subject except in a scenario in which there is only x. All good, all clear? So now this thing is done. Something like that, something like that. You can try it out. Now let's look at these past paper questions. And that is the kind of ending to it. Past paper questions. So let's look at question 15. Now the question says the line x plus y is equals to 2 and x minus 3y is equals to 6 are shown on the diagram in the answer space. These are the two lines. Which one is which? Let's see. So x plus y is equals to 2. When x is 0, y is 2. When y is 0, x is 2. So this is the blue line. That is x plus y is equals to 2. And the other one, the green line, that is the other one, that has to be the other one. That line is going like this. So two lines are drawn for you. Find the gradient of this line. It is just basic coordinate geometry. Negative 3y is equals to negative x plus 6. 3y is equals to x minus 6. Y is equals to x over 3 minus 6 over 3. So the coefficient of x is gradient, that is positive 1/3. Nothing is done. On the answer, on the diagram in the answer space, this is the answer space. Shade the region defined by the inequality, this, and x plus 1 is greater than or equal to 0. So this one is x is greater than or equal to negative 1. So let me draw this line in purple color. That is x is greater than or equal to negative 1. So this is the line like this. All these lines are solid line. Why? Because they all are inclusive inequality. Now we are looking for this thing. First of all, if I talk about the blue line, x plus y is equals to 2, it's below the required region. Shade the region. This is below this line. So it has to be below the blue line. X minus 3y is less than or equal to 6. In other words, if I make y the subject, because the coefficient of y is like this, so therefore x minus 6, and this is lesser than or equal to, this is like 3y. Now read it like this. 3y is greater than or equal to x minus 6. So this is a star equation. So now we have the green line. This is above the green line, because we are reading it from the perspective of positive y. Very, very important question, because it signifies the significance of reading it from the right perspective. Read from the perspective of y. And then last but not the least, the purple one, x is greater than or equal to negative 1. This is right of the line. So now it's below the blue line, it's above the green line, it's right of this line. Therefore, this shaded region is what is required. So therefore, shade the region Therefore, this is the region that needs to be shaded, and it is this orange region that I am shading. So this is the required region R, and that is the answer. All good, all clear. So let me write the blue color thing. This is x plus y is less than or equal to 2. The green color thing, that is 3y is greater than or equal to x minus x. 3y is greater than or equal to x minus x. And the purple thing, that is x is greater than or equal to -1, and it's in between all of them. Now let's look at this. Another past paper question. The question says 3 lines are drawn on the diagram in the answer space. The equation of line L1 is y is equals to x plus 5. Which one is y is equals to x plus 5? This is this one. It has a positive slope and it's passing through 5, the y-intercept. So this is line L1, and I think they have also labeled it. So I can, yeah, there it is, L1. So let me choose red color for L1. So y is equals to x plus 5. That is the first one. And the next one, the blue color, 3y plus x is equals to -3, line 2. 3y, it has a negative gradient, so that is the blue line that's going like this. And use diagram to solve the simultaneous equation. I think that is kid stuff. Let's ignore that. Write down the equation of line 3. So now the green line, I'm interested in this, and we are interested in finding this equation. So now I can see that this change in y is 4, the change in x is 4, and it's going down, so the gradient is -1. So let me work it out over here. We have 0, 4, we have 4, 0. We calculate the gradient 4 minus 0, 0 minus 4, that comes out to be -1, and this is the y-intercept. So C is 4, therefore y is equals to minus x plus 4. This can also be written as x plus y is equals to 4. So that is the green line, line 3. The equation of another line, L4 is y is equals to -1. Draw this line. So let me draw it in purple. Y is equals to -1. There is the line. This is y is equals to -1. That is line 4. And then it says the region enclosed by these 4 lines is defined by 4 inequalities. One of this is this. Write down the other 3. So now let me just shade the region so that you have a pretty good idea exactly what is the shaded region. This thing is the shaded region. So it's going like this and like this and then like this and like this. So this is the shaded region. How many boundaries does it have? It has 4 boundaries. So let me just focus on those 4 boundaries. So let me just draw, this is the red line. That's like this. And no, not this thing. Let me draw this. This is the red line. This one is the green line like this. This one is the blue line like this. And then there is a purple line that goes like this. Now you can visually see it very, very clearly. These are 4 things that you see. Let me just erase this shading. Okay. So let me just completely erase this. Stroke eraser, that thing is there. Now it's below the red line. It's below. It's below the green line. It's above the purple line. It's above the blue line. So 2 below and 2 above. So red one is line 1. Line 1 is y is equals to x plus 5. So let me write over here. Line 1, y is equals to x plus 5. Line 2 is, let me write line 3 first in green color. Line 3 is y plus x is equals to 4. So this is line 3. This is line 3. y plus x is equals to 4. Yeah, x plus y is equals to 4. And then we have the blue line, that is line 2, that is 3y plus x is equals to negative 3. Line 2, 3y plus x is equals to negative 3. And the last one, the purple one, is line 4, that is y is equals to negative 1. Now focus on it again. It's below red, below green. It's below red, so less than or equal to this thing. Below green, less than or equal to 4. It's above blue, greater than or equal to, greater than or equal to. This was already given. So basically this and this and this, that is what you have to write. Y is less than or equal to x plus 5. X plus y is less than or equal to 4, y is greater than or equal to negative 1, and that's how this question is completed. And another question of the same type. In the diagram, the unshaded region R, now they're talking about unshaded region, is defined by 3 inequalities. Y is less than or equal to 2x plus 2. So again, let me use red color. 2x plus 2, I can see the y-intercept, so let me just draw this. I need a line. This is the first one, y is less than or equal to 2x plus 2. And then the blue one, that is this one. Now it depends on your experience, otherwise you have to do the calculation. Now let me give you a small hint. If this y-intercept and this y-intercept is the same, it's of the form x plus y is equals to a constant. So if I take this over here, this is x plus y is equals to constant, that constant is 5 in this case. And now the third one, that is the green one, that is this. Okay, so now 3 lines are there. Write down the third inequality. So now the third inequality, the green one, that is, this is the y-intercept, this is 4 comma 2. Gradient, I can see that is 2 over 4 or half. Y-intercept is 0, y is equals to half x. It is below the red line, it is below the blue line, and it's above the green line. So therefore the inequality is, it's a solid line, right? So y is greater than or equal to half x. And that's how this thing is done for 1 mark. Y is greater than or equal to half x. And last, a simple inequality in which you have to make x the subject. 2x lies between 4 minus 13, 9 minus 13. 4 minus 13 is how much? Negative 9. 9 minus 13 is how much? That is negative 4. Divide by 2, we get 9 over 2, which is negative 4.5, and this is negative 4. Find the integer values of x which satisfy the following inequalities. Now let me just double check my working. 4 minus 13, that is negative 9. And 9 minus 13 is negative 4. They both are negative. And when we divide by 2, 9 over 2, that is negative 4.5, and this is 4 over 2, this is 2. I think a small mistake I did. I forgot to do the division. That is 2. So what are the numbers that lie in this region? So let me draw a number line. This is negative 4.5. This is negative 4, this is negative 3, this is negative 2, this is negative 1, and so on. We are looking for integers between these two values. And let me draw a line between them. So now what are the integer values do we see? We see a negative 4, we see a negative 3, we see a negative 2. Therefore, the integer values is negative 4, negative 3, negative 2. Find the integer values of x, and that's how this is done. So now we are done with lecture number 22 of algebra and linear inequalities, the basic, part 1, the basic, Part 2, the graphs, it's all done and dusted. Till the next class, take care, and there's much more to come.